And I'm going to tell you, some students didn't get it right. I'm going to explain to you how you can do it. Okay, so let's take a look. So there are several tips, several hints for you to watch out what kind of data it is. Okay, so let's see. So they were talking about health expenditures. So that related, how much it's going to cost. So this doesn't look like a categorical data because we are not dividing people into two different groups, people who are paying a lot versus who are not paying a lot. So that kind of data is categorical. But this is not. This is numerical data. We are talking exactly how much they are paying, right? Okay, and I know this part can be a little bit confusing because some students might be looking for the key. They might see this percentage number. They were like, wait a second. When we see percentages, we are dealing with proportion problem. Proportion problem is always for categorical data. Maybe this is a categorical variable. But this phrase, this word, or maybe this percentage was placed there to trick you. This has nothing to do with the data. 70, it could be 20% of the GDP. It doesn't mean anything as far as this question is concerned, right? Okay, so this is a numerical data. And I want to emphasize, how you work on this problem. Whenever you work on this problem, it's very, very important you write out all the information you have, right? Okay, so we have to do that as well, okay. So before I jump into this question, part A, we want to talk about how we can solve this problem. That means we have to analyze all the numbers we have, right? Okay, so the first thing is, I'm going to ask you, do we have the population mean here? Okay, do we have the population mean? If yes, what is the population?
It's 8,086.
This one, right? Okay, you guys got it right. Okay, so 8,886, right? Okay. So how do I know it's a population mean? It looks like it's a mean. Okay, it's very specific, very clear in the question. It says this is a population mean, right? I try to start using the sample we just learned because it's gonna keep you, help you memorizing them. Okay, and the next one is, do we have the sample size? I'm gonna use a small letter n, remember? Okay, do we have the sample size then? Sample size, do we know what the sample size is?
100.
100, 100, right, is given here. We'll take a sample of 100. You guys see it? Right, okay, so it's 100. Very, very important you write it out, Okay, population standard deviation. Do we know the population standard deviation? This is easy. 2,500, right? Okay, great. Okay, so it is very, very important you write out those three variables information first before you attempt the question. So let's take a look at what the question asks us to do. Okay, so it says you want to work on a sampling distribution. So this is clearly a sampling distribution problem we were talking about. Sampling distribution talks about the distribution of a statistic that you take from a sample. And the sample we have here is 100 people. Okay, sampling distribution of the mean upon a healthcare cost for a sample of 100 people. So that means we were asked, what is the distribution of the X bar, right? What is the distribution of the sample mean? I hope you remember X bar is the sample mean. So we were asked, what is the distribution of it? Right, okay. So we were talking about we can use a CLT to solve this problem. So we're gonna use a central limit theorem to solve this problem. Okay, before we jump into the central limit theorem, we're gonna talk about bell curves and things like that. We have to verify the assumptions of the central limit theorem. Okay. So what is the assumptions of a central limit theorem? What is the assumption of the central limit theorem, remember?
Have to have at least 30.
Yeah, sample size to be at least 30. Do we have at least 30 people here? Or maybe, yes, right? So, assumption, you can talk about assumption assumption is valid. Assumption. Okay, I would say assumption is met. Okay, it meets the assumption of the central limit theorem. And now we're going to use central limit theorem. Okay, so I'm going to write down from the central limit theorem, from the CLT, what we know is, I'm going to write it out. Okay, hopefully you remember as well. So the sample mean, okay, it's going to follow a bell curve or normal distribution, right? Okay, so the distribution of the sample mean follows the normal distribution. And the mean of the normal distribution is the population mean, which is given here. And the spread of that bell curve is going to follow this, expression, and we can compute it, right? Okay, so is this part clear? Okay, now I'm going to plug in the numbers. It shouldn't be difficult. Okay, so let's try. Okay, let's try. Okay, so from this one, what I know is X bar. Okay, I'm going to just write it down here. Remember, X bar is sample mean. Okay, X bar is going to follow a normal distribution, right? Follow a normal distribution. Okay, I'm just going to write this way. Follow normal distribution. Remember, normal distribution has two numbers. We need a mean and a standard deviation. The mean is mu, which is 8,086. Right, okay. So this is simple. Just plug in the numbers. It shouldn't be difficult. The next one is a sigma over this one. Sigma is 2,500 over square root of 100, all right? Okay, is this part clear? I'm saying, you know, just simple math. You just plug them in. Okay, I'm just going to plug them in here. Very, very important. You guys bring a calculator with you as well, right? You know, you definitely want to bring a calculator because, you know, because we are sitting in front of, you know, computer, you probably can use your Excel to do it as well. Okay, so what number do you guys get? So what exactly is this? So this is a normal. I know the mean of it is 86. That wasn't a problem. Okay. And so how about the standard deviation? What number do you guys get?
250.
250, right? Great. Okay, now we have the mean of this bell curve. We also have the spread of the curve. Okay, now I'm going to tell you one more terminology. I think this is one of the last terminology I'm going to talk about here. Okay, so let's see. So this quantity is called standard deviation of the sampling distribution of the sample mean. What do you like that name? How do you like the name? Do you like it? Is it very long? It's very, very long, right? It's called standard deviation of the sampling distribution of the sample mean. This is really, really long. Okay, I don't like that name. Okay, if you watch the video, you know it has a different name. What is the different name called? What is it called? What else is this quantity called? Yes, what is it called? Standard
error.
Yes, great. You know, I'm sure some of you guys watched the video. Standard error of the sample mean, right? Okay, so this quantity, sigma over square root n, is also called a standard error of sample mean. So it's much easier. Okay, so sometimes you see the question, it may refer as a standard error of the sample. Okay, great. Okay, so let's see. So I think the question asks you to fill in the blanks. Okay, so let's take a look. So the first one asks you E. Okay, so E here, E here represents expectation. Okay, so basically it's a different way of writing it. So E represents expectation. It just tells you where on average do you think your sample mean is gonna be. Okay, so you should, if you do have a bell curve, okay, if you have a bell curve, wait a second, the bell curve, yes. If you have a bell curve, okay, we should expect on average is gonna appear at the mean, right, the center of this bell curve. So what do you think the E sample mean is gonna be? Where do you think the expectation of the sample mean is gonna be? 0, 250, 8,086? Yes, right? So the center of this bell curve for expectation is just gonna be 8,000. Yes, it's just gonna be 8,086, right? Okay. And the next one you were asked standard error of the sample mean, which we have already calculated. It is 250. You guys see it, how I got it? Is it clear how I solved the part A? Okay, okay, good. And so let's take a look at part B, right? Okay. So part B, okay, so I'm gonna explain to you how I go over this kind of problem. Okay, so there are some keywords you guys should always pay attention to. Okay. So what is the probability? What is the probability of the sample mean will be within plus minus $200 of the population mean? So there are like a lot of information going on here. So first thing you want to talk about is, you want to focus on here is this question asks you about a sample mean probability. So this one talks about sample mean So that means we talk about the distribution of the sample mean. This is a sampling distribution problem. Again, you should use the central limit theorem, which we have already done that in part A. The next hint you guys should focus on here is you were asked to find a probability. Okay, so I have already mentioned this time last class. Whenever you work on a probability problem, you have two approaches. So I'm just gonna type it out here. So there are two approaches. You can method 1 to find a probability, and there's a method 2. Okay. So what is the first method to find a probability? How would you find a probability? We have already done plenty of exercise last time. How did I solve the probability? Did I just come out with those numbers on my, in my head, or make up some fake numbers? How did I got those probability, those numbers between 0 and 1? How did I? Do you remember how I did it last time? Yes. I used the Z table, right? You guys remember? Okay. So method 1, whenever you see the word probability, you should know that you should use a statistical table. So far, we have only learned the Z table, but later on, we're going to change it to some other table, right? It's going to be a Z table, some other table. Okay. And then method 2. Okay. So there's also a second method, which we talk about briefly towards the end of last meeting. Okay. So how do I find those probabilities? Actually, I memorized some numbers in my head, right? What are those numbers are? Do you remember 3 magical numbers? What is it called? It's a rule.
The empirical rule.
Yes, you use the empirical rule, right? Use the empirical rule. Right, okay. So empirical rule is a simplified version. It's very simple. It only has 3 numbers. There's small numbers we derived. Okay, they are fairly similar to statistical tables, but they are not exact. Right, only 2 methods. When you see probability, you're gonna use either this one or that one. Majority of the time, I would say 95% of the time, you're gonna use method 1, unless the question says use empirical rule. Otherwise, you will not. You will always use the statistical rule unless the question asks you to use the empirical rule. Right? Okay, good. So 2 different methods. Okay, so let's see. So I'm going to find the probability of this sampling distribution. So it's very important. We are going to write it out, right? We're going to write out a statement. Okay, so what we want to do is we want to find the probability. Okay, we want to find the probability of a sample mean, right? Sample mean is X bar within plus minus 200 of a population mean. Okay, so what is the population mean? Do we know what the population mean is? It says within plus minus. Within plus minus, that means is, okay, so how would you phrase it? Population mean, plus minus 200 population mean.
Is it just 0?
Or
like in between positive 200 and negative 200?
You are absolutely right. Okay, so it's going to be in between, right? Okay, so I'm just going to put this less than and less than here. So on the left-hand side, X bar has to be more than the population minus 200. Okay, I'm just going to write down here. Okay, so you're going to see how I did it. Population mean minus 200. On the right-hand side, it's going to be population mean plus 200, right? Right, okay, does it make sense what I'm doing? Because it says within plus minus 200. So it's going to be less than population mean plus 200, but also more than population mean minus. Okay. So do we know what the population mean is? Do we know?
Can you use the empirical rule for this?
Oh, well, you could. Well, I don't think you can, because the reason is because 200 is not exactly 1 standard deviation. Remember, empirical rule is only about plus minus 1, plus minus 2, plus minus 3. 200 is not a 1 standard deviation, right?
Okay, I was just curious because 200 is divisible by 2, so I was wondering if it
I see. Okay, good. 200 is divisible, but the key is to see how many times is 200 to 250.
Oh.
Okay, you can use the empirical rule if the question is 250. You could also use the empirical rule if the question is 500, because that's twice of the standard error. Right? Does it make sense? You guys know what I'm talking about here? Okay, but right now you cannot use empirical rule because this is not exactly, this is not a 1 standard deviation, not 2 standard deviation either. You can only use the empirical rule for a whole number, right? Okay, good. And so let's take a look. And so population mean minus 200. Okay, so what is a population mean? We have it here, right? So it's very important that you write it out. It's 8,086. So you're gonna minus 200. Okay, make sure you guys have a calculator. Okay, right, make sure you guys have a calculator. And okay, so you're gonna copy the sample mean here. Okay, on the right hand side is gonna be 8,286. Right, okay, so hopefully this part is straightforward to you. And how do I continue from here? Okay, what I have here is a probability question, and we talk about there are two different methods to solve this one. So, you know, I've already said we cannot use empirical rule. You guys probably know I have to use the statistical tables, right? So what table I'm gonna use here? We only learned the Z table. We have to use the Z table. Okay, so how am I gonna use the Z table? How am I gonna use the Z table here? Okay, so are those numbers, can I look it up from the Z table?
No, would you like
Yes.
divide it over the square root of the small n?
You divide it by the square root of small n, right? Okay, so let's take a look. Okay, so let's, I think you are definitely on the right page. We want to convert this in terms of z-score. Okay, I'm gonna write out a z-score formula. It's very, very important. Okay, I'm gonna write it down here. Okay, maybe I don't. So z-score, this is very important. So it's gonna be, I've already written out before, observation mean minus standard, observation minus mean divided by standard deviation, right? So this is the formula. Okay, so now you want to focus here. What is the observation here? Observation is, this is the observation, right? Okay, so I'm going to plug in a number here. I'm going to use a 7886 over here. Okay, so let's
Is that just from the problem? Where'd you get those numbers?
Which number?
7,886 and 8,286.
Good question. The reason is because it's going to be population mean minus 200, and we know population mean, which is given here, right? Okay, so you can replace the population mean by 86, right? Okay, you do the same thing here as well, right? Is it clear what I'm saying? Good.
Okay. Yeah.
Good. Okay, so I'm not done yet here, right? I'm not done here. Okay, so we want to convert 7886 in terms of its corresponding z-score. This is very important. I want to convert this into a corresponding z-score. Okay, so it's very important that you see that 7886, it is observation here. You still have to subtract the mean divided by standard deviation. You do not want to divide by standard deviation right away. You want to subtract the mean. Okay, and so let's take a look. So it's gonna be minus the mean. Okay, so what is the mean here? Do we know what the mean is? What is the mean? So I'm working on a problem dealing with x bar, which is the sample mean. I'm talking about the distribution by x bar. Do we know what the distribution by x bar is? We know that the mean of the sample mean is 8,086. So 86. So this is the mean. Okay. So this is what I'm doing. So this part is a little bit tricky, you know. Very, very important. So this is the mean. So observation minus the mean. Okay. I have to divide it by standard deviation here. Okay. So now I want you to think very, very carefully what standard deviation I want to divide it by. We have a bunch of standard deviation here. Okay. So let's take a look. We have population standard deviation. We also found a new standard deviation, which is the standard error of the sample mean, 250, which is also given here. So which one do you think I should divide it by? Should I divide by population standard deviation? Or maybe I should divide by the standard deviation of the sampling distribution of the sample mean? What do you think I should divide it by? Is it 250 or maybe 2,500? Okay, this part it should be 250. Okay, I know this, a lot of students get confused with this one. The reason we do that is because you want to look carefully, okay, very, very important. We were working on X bar. We are working on a problem with X bar. You should talk about the distribution of X bar. And X bar follows a normal distribution. We talked about this before. And there's a mean, and there's a standard deviation, which is 250, right? So there's a standard deviation, which is 250. Right, okay, so you want to divide by the standard deviation of X bar, nothing else. Okay, is this part clear? If not, I can repeat myself. Okay, you do exactly the same thing here as well on the right-hand side, which is 8,286. So you do the same thing. This is observation minus the mean, which is what we have here. And then you divide it by.
So on either side, you're going to end up with positive and negative 200 over the square root of 250.
Yes, you're absolutely right. So you see that actually you don't have to do this additional step. You can just use a minus 200 over 250. Plus 200. On the other hand side, it's going to be positive 200 and 250. But the reason I do this extra step is just to make sure none of the students is confused, because this part is what is the this is the standard procedure to work it out, right? Okay, sometimes you do a lot of calculation in your head. Sometimes you get confused. It's easy to get confused. That's why I like to do it the tedious way, but just one more step. Okay, so it's gonna be minus 200 over 250 and z, and this is a positive 200, 250, right? Okay, and so you can convert them in terms of decimals, and this is minus 0.8, and on the other side is gonna be positive 0.8, right? Okay, hopefully you guys see the pattern. Okay, so I'm gonna ask you one more question. What are those numbers? 0.8 minus 0.8, are those probabilities or those z-scores? So this part is very, very important, especially at the beginning of the term. I like to repeat myself many times. And the reason is because, it's very essential that you differentiate those numbers. Are those probabilities or they are z-scores?
Z-scores.
Scores.
Yes, very good. So we want to find the probability using the table, and we know that we have two z-scores. Okay, so one of the z-score is a positive 0.8, and the second one, 0.8, and the second one is a minus 0.8. Okay, so this is a z-score, positive 0.8. Okay, what I'm gonna do is I'm gonna find the probability corresponding to this 0.8. And the reason I'm doing that is because you probably remember I've already done this last time. Okay, give me a second, I'm gonna clear some of the, okay, so the reason I'm doing this is because we want to find a probability in between. I've already done this last time, I'm gonna do it again in case. Okay, we're talking about bell curve, but this is not any bell curve. This is a distribution of X bar, right? Okay, so the center of this, okay, the center of it is 0 z-score. Remember, you can label your curve using two sets of numbers, actual observation or z-score. So this is a z-score. And what we want to do is we want to find minus 0.8 versus positive, right? 0.8. Okay, so what we want to find is the probability between those two. So the probability between those two represents those numbers, right? Those are numbers between them. So the probability means the area under it. So this is what we want to find. And you probably remember from last time, to find this one, what you need to do is you're going to do it twice. First, you look up the z-score for positive 0.8. You're going to find the area to the left. Remember, z-table is always to the left. You're going to find the area to the left of this one. So that means everything to the left, including this white tail. And then what we're going to do is we're going to do the second time, find the probability, find the area to the left of a negative 0.8. So that means we're going to find this one. And you're going to use a bigger probability minus this small corner. What you have the left with is going to be the one shaded in the middle, right? So you're going to do it twice. And we're going to do it twice. So you can see this is what my plan is to do this. Oh, hold on a second. I'm going to do it twice. The first time is I'm going to find a positive one and find a negative one. Okay, great. We have our tables here. Okay, I'm just going to clear my drawing. Okay, so let's do it. Positive 0.8. Okay, so we are on the negative side, so let's find a negative one first, the second one. Minus 0.8, minus 0. Okay, is it too small for you guys to see? Is it too small? I can zoom in. Okay, I'm just going to zoom in. I didn't hear any response. Okay, so minus 0.8. Minus 0.8, you guys see it here. Okay, very important you read it right. Okay, so this one, right, is right here, 0.2119. Okay, so you want to write it down here, 0.2119. You're gonna do the same thing for the positive one, which is on the other side, all right? Okay, so positive 0.8, again, you can see the area is always to the left, right? Okay, so positive 0.8 is right here, is right here. right? Okay, so I'm gonna write down here 0.7881. Okay, give me a sec. Great, okay. So I have those two, and as I said, I'm gonna use the bigger one minus the smaller one. Okay, so you're gonna use this one minus this one. Hopefully you guys are working with me. You should be able to get the number, right? Okay, so the number is 0.5762. Is it clear how I solve this problem?
Yes.
Great, great. Okay, so let's take a look. And I think, well, I'm going a little bit too slow. I was hoping that you guys will also work on some of the exercise. So the next one is, what is the probability the semi-mean will be greater than 9,000? This part is fairly similar to what we had before. So the key part is to make sure you write it out as a statement. Okay, so let's see. So we want to find the probability of a sample mean more than 9,000. I like to write it out in terms of this one. And as you can probably see, I cannot use 9,000 right away. This is actual observation. It's not a z-score. I mean, I need to convert it to z-score. So you can do the same thing using 9,000 minus the mean, minus the population mean, divided by the 250. You guys remember? Okay, so you can convert it. And that's going to be z, you can convert it to z more than 3.656. Okay, so this is a number. Okay, the question asks you to leave it in 4 decimal places. I would recommend to be sure during the intermediate steps, you use at least 5 or 6 decimals. You know, sometimes there may be a rounding issue, but Cengage typically doesn't have the issue because I do give you some uncertainty like a tolerance. If you're close enough to the answer, you'll be marked right and in the exam as well. Okay, I want to show you how you can find this problem, how you can solve this problem. And I'm going to use the z-table to do it because the question didn't say anything about empirical rule. We want to find the probability z more than 3.656, right? 3.656. Typically, the first thing you do before you run it to the z-table, you want to, before you look up your z-table, you want to round your z-score to 2 decimals. And the reason you do that is because this table is only...
Wait, can you explain how you got that 3.656 number again?
Yes, okay. So I want to find a z-score. And we have the formula is given here. Observation minus mean divided by standard deviation. So observation is 9,000. And I'm going to minus the mean, the population mean. Let's take a look. The population mean is 8,086, and we have to divide by standard deviation, which we found here 250, right? 250. You guys see it? So I'm going to minus 8,086 and divide by 250, right? Okay, so let's take a look. And so this is exactly what I want to do, right? I think if you plug all those numbers into your calculator, make sure you bring a calculator with you for my meetings, for the meetings. And so this is how you got it. Is this part clear? Okay, so I'm going to round it to 3.66. Remember I said you want to round it to 2 decimals before you look up the table, 3.66, right? Okay, so let's take a look. So first thing you want to pay attention to is we want to find the area to the right, This is more than. So you want to find the area to the right. The table gives you the area to the left. So what would you do? How would you solve this problem? You want to find the area to the right, but they only give you the probability to the left. What would you do? You're going to subtract from 1, right? Okay. Right, subtract from, yes, I think that student got it right as well. So subtract from 1. Okay, so that's okay. Let's look for 3.66. Are you able to find 3.66 from your z-table?
No.
What is the largest z-score you can get on this table? What is the largest z-score? 3.9?
Yeah.
Or 3.09?
3.09.
Yes, 3.09. You see, 3.09 is the largest one you can get. Okay, so 3.66 doesn't appear here. Okay, so let's take a look at what does it mean. Okay, so I'm gonna use an annotation here. Okay, so this is a standard normal, standard z, okay, z. Okay, the largest one we have is 3.09. Okay, and according to the table, the area to the left of 3.09 is 0.990. The largest probability you can ever get in this table is very close to 1, is 0.990. So that means, okay, so that means to the left of a 3.0, hold on a second. Okay, so to the left of a 3.09 is almost close to 1. Okay, now if we want to move a little bit further, we want to consider 3.66. It's going to be somewhere here. What do you think the probability to the left of 3.66 then? Is it going to be fairly close to 0 or fairly close to 1? I'm talking about the area to the left of 3.66.
Really close to 1.
Fairly close to 1, right? So that means the area to the left of 3.66 is almost close to 1. And we are going to subtract this number from 1 to get the area to the right of it. So that means this part. So this is going to be fairly close to 0. Fairly close to 0, right?
Close to 0 or close to 1? Didn't you say 1?
Close
Oh. Wait.
Right? Yeah, it's very important to differentiate. Are we talking about to the left or to the right? To the left is 1, to the right is 0, right? You can think about it. Anything beyond 3, you know, anything beyond 3, that means more than 3. Very, very unlikely, 0, right? Okay, so what is the probability the sample mean will be greater than 90/100? Unlikely, almost a 0, almost a 0. The question asks you to leave it in 4 decimal places. You can do this. But I think if you put 1, you are going to be graded right as well. Okay, I'm going to clear this one so we can work on the part D. Okay, so let's see. So if a survey research reports a sample mean, okay, somehow a survey research firm reports a sample mean X bar greater than 90/100. Okay, so just say someone came with an X bar which is more than 90/100. It says as a 10,000, which is more than 90/100. Okay, would you question whether the firm follow correct sampling procedure or not? What do you think? Do you think they follow the correct procedure, and why? We have already calculated in part C, the probability is almost 0. That means it's very unlikely. And now they came out with something which is more than 9,000. Do you think it's likely? It's very unlikely, right? So they probably did not follow the correct sampling procedure. The reason is because it's very unlikely to have X bar which is greater than 9,000. Very, very unlikely, right? So the answer should be, I would just say very unlikely. Very small chance that they will come out with anything that's more than 9,000.